Hey guys, my name's Frank, and this is my workshop. Hey guys, I'm calling this video episode 1 of the mini dozer build, the Genesis. So this is, I haven't started actually building anything yet. This is the design or the planning process that I go through for a custom build like this. I mentioned in the comments and maybe in an earlier video that my plans included building a mini dozer from Cub Cadet components. That's probably at least as ambitious as the motor grader, and I'm going to use the same process for this build as I did for the motor grader. The idea of the motor grader was to build a scale model. It's approximately 1/3 scale. It's 13 feet long. Typical motor grader's 40 feet long. So what I thought I would do is spend this video going through the planning, the early planning phases, conceptual plan, talking about some of the components I'm going to use and how I'm going to approach this build. The idea is to build something which looks like a scaled down Caterpillar. It won't be accurate in every detail. Obviously it's a garden tractor at its heart, but a lot of the design features will be scaled down from a dozer. All right, so what I'm going to use as my model is this Caterpillar D10. So this is my idea for the scale design, right? So I'm going to use this diagram and scale off of it to Cub Cadet scale what the components should look like. So things like the height of the track here, from the ground up to the drive wheel, the length of the tracks, the size of the blade, the design orientation of the hydraulic cylinders on the blade. I don't think at this point I'm going after the ripper. Maybe something in the future. I probably will accommodate something like that in the future, but that's not in the immediate plan. So how do I get from this to, you know, a Cub Cadet size? All right, so I thought I would explain how I do that, give you guys some insight into the process so that, you know, you potentially can do that for yourself. All right, so the overall length is 66 inches, 165 centimeters, or 1.65 meters. The height from the top of the steering wheel to the ground is 36 inches, or was that 90 centimeters. Okay, so this gives us the base dimensions of this. All right, the D10 Caterpillar is about 20 feet long, which and then the blade is about 5 feet. So overall, with the blades, 25 feet. So we can scale the rest of the dimensions off of that. We just really need one dimension there. So 20 feet. Is 6 meters, right? 6 meters, and then you're 1.5 meters. Okay, so if the length of the track is the overall length of the machine is 20 feet, and our Cub Cadet overall length is 5.5 feet, then we can create a ratio, and then we'll use that same ratio for the rest of the dimensions. All right, so with the length of the D10 20 feet, length of the Cub Cadet 5.5 feet, then 5.5 divided by 20.275. So our overall scale will be 0.275, which is close to, I don't know, it's probably closest to 1/4 scale. 0.25 would be 1/4 scale. So somewhere between 1/4 and 1/3. So 0.275. So we can call it a 1/4 scale build. Okay. So using a ruler, we get 5.5 on this drawing. 20 feet is 5.5 inches. So we want to get the dimensions, per inch. All right, so each inch on here is 3.6 feet. All right. So measure the height of the track from the ground. I have 2.5 inches, so 2.5 times 3.6 equals 9 feet. So that's 9 feet from the top of the track to the ground, about a little under 3 meters. So if the length of the tractor is 66 inches or 5.5 feet, how tall is the track? So it's 0.275. So instead of 9 feet, 9 times 0.275 equals 2.4, 2.5 times 12 inches is 30 inches. So it's showing the height of the track to be 30 inches. So track height (30 inches). Track length equals 20 times 0.275, 5.5 feet, which is the length of the tractor, or 66 inches. All right, so let's compare the two. The track height is 30 inches, track length is 66 inches, so it's a little more than twice the height. Let's see if that holds true for this diagram. It's 2.5, and we said it was 5.5, so that's right. Okay. Let's look at the diameter of these. The drive wheel here, it's about 1.125 inches. So 1.125 times 3.6 feet. So that's 4 feet. Looks like it's 4 feet in diameter on this diagram. And we're going to do 0.275 scale. So it looks like a foot, a little bit over a foot. So this drive wheel diameter is 12 inches in diameter. All right, let's look at the bogey wheels. They're look like 7/8. So 0.875 times 3.6 equals, so these are 3 feet in diameter times 0.275, which is our scale factor, is 10 inches. So end sprockets or end wheels are about 10 inches. End wheels equals 10 inches in diameter. Okay. We need to find the track width. All right. It's the dozer is 12 feet wide with the track from outside the track to outside the track. So let's figure out what the width of the tracks is. That's 2 inches on the ruler. So it's 6 feet per inch. If it's 2 inches wide and it's 12 feet, so it's halfway across is 6 feet. That's about 1 inch on this picture. And the width of the track on this picture is 7/16. So that's 0.4375 times 6 feet is 2.6 feet times 0.275. Our scale factor is 8.5 inches. So the width of the track here is 8.5 inches. So track width 8.5 inches. All right, so that gives us a lot of the dimensions we need for this basic arrangement here. In terms of the height of the track, the width of the track, the length of the track, the dimensions of the three main, the drive sprocket and the front and rear wheels. Then the overall height of the tractor here. I'm not sure whether I'm going to modify the hood. My tendency is to keep the hood the same, so it'll look like a Cub Cadet. It will take me probably a mock-up of the track area, because this will be the first thing I'll build is the track frame and the drive system. But the distance dimensions on here will drive the rest of the design features. Obviously, I'm going to have a seat. The seat may well be down, you know, at the track, within the track level. So we'll see what that looks like once we get some of this other stuff mocked up. The other thing I want to know is the center to center distance here from the two, for the two drive, the two track wheels. All right, it's 4.5 inches. All right, 4.5 inches times 3.6 feet per inch, 16.2 feet times 0.275. So, which is our scale factor again. So roughly 4.5 feet, 4.45 or roughly 4.5 feet. This is 16 feet, a little over 16 feet. So the wheelbase, I'll call it the wheelbase, the distance between the center line on these two wheels. Wheelbase is 4.4 feet. Maybe it's, 50, 54, 53, 54 inches. Okay. So that gives us the basic layout dimensions for the track system, and everything else will be based on, on that design. There may be issues that I run into that will cause me to deviate from these dimensions, but these at least give me a starting point. They allow me to determine how much steel I need to order for the frames to support the track system, and support the system between the two track systems underneath the tractor. All right, so let me give you an idea of how we're going to build this. I'm not an artist by any stretch of the imagination, so bear with me on this as I try to explain what I'm going to do. All right, so I'm going to make 2 frames, and I'll do one here. It's going to be a C channel. And a second C channel behind it. Okay, so between these 2 C channels will be the drive, the front and rear drive pulleys that the track will run on, and then mounted above this on a pivot arm up above this will be the large, on the D10 it's the drive wheel. On mine it's going to be a tensioner, so I'll have a tensioning mechanism to push this lever arm up to create tension. So the track will run like that. And this pair of C channels, between them at the bottom will be the bogies. I mean, they're between the two that will support the bottom of the track off the ground. And then there'll be an identical track frame on the other side of the tractor, and they'll be fastened together with a series of square tubing running crossways, and these pieces of square tubing will support this frame, and they'll run across and under the tractor frame. So maybe, you know, aft and forward. Okay, so that's the basics of the track frame, and those will be the first things I build. Okay, so how am I going to drive the tractor? What's the mechanism, and how am I going to drive it? All right, I'm going to use 2 Cub Cadet axles, and each axle is each hydrostatic axle has it's a open differential. So when you stop one side, one wheel from spinning, the other wheel spins. So what I'm going to do is I'm going to disengage that, so only one side drives, and I will have this sprocket drive on the one side of the tractor and the rear sprocket drive on the other side of the tractor. And I will use 2 Cub Cadet rear ends, one in the front and one in the back. And the front one will drive one side, the back one will drive the other side. They're hydrostatic, so the speed control is by a little lever, the swash plate lever on the side of the hydrostatic transmission, and I'll create some levers at the driver position which will pull the swash plate actuator forward and aft on the 2 transmissions. The engine will sit here in the middle. We'll drive this one by a drive shaft and the rear one by a drive shaft as well. One of these will be turned around, or actually they'll both be turned around, the engine will be turned around. So that will allow me to drive both transaxles by drive shafts from the engine forward and aft. And that way I can provide power to this drive sprocket and then the left rear drive sprocket independently, because I can control the transmissions. They're variable, infinitely variable transmissions, independently operated. This side will just roll and this side will just roll. Okay, so what do the transmissions look like? Let's go take a look at one of the transmissions. All right, here's one. So this is a hydrostatic transmission and rear axle out of a Cub Cadet. And this is the rear differential cover. We've got axle tubes on both sides supporting the drive shaft, and you can see when this one, if I spin this one forward, this one goes backwards. I mean, so this is an open differential. There's a gear case in here, which is really just a reduction gear, and this is the hydrostat hydrostatic transmission. So the hydrostatic transmission has an input shaft here, and it actually has a second input shaft right here. So you can drive this transmission from either end. This is what's called a charge pump. There's a small gear pump inside this housing which generates head pressure for the hydrostatic transmission. There's a variable displacement pump and a constant displacement variable speed motor at the bottom, and this of course is a hydraulic filter. This is the swash plate actuator. There's really only about an inch of movement, but this is from full forward, which is about 8 miles an hour, to full reverse. Actually, it's the other way around. Pushing it back is forward motion for the axle. About 8 miles an hour is tractor speed, and then full reverse is about, I think it's about 3 or 4 miles an hour. All right, so that gives you an idea of what the two axles will look like. I mean, this is what they're going to be. I have two of these drive axles. The width here, I'm going to have to extend these flanges. This is the drive flange that the wheel bolts to. This width is the normal width on a Cub Cadet tractor, and we obviously use have the same axle, here on the motor grader. Okay, so that's the plan. That's one axle. The other axle, rear end actually, is here. It's sitting with the rear cover down, filter faced up. So anyway, that's the second rear end. So I've got the two rear ends that I'll need to get me started. I'm going to continue to work on the plans. I'm going to buy some steel over the next month or two. As I make some progress, I will share it with you guys. I do have a new tool coming, which I will do a review of. So you can look for that in the next couple weeks. I think I'm going to get it tomorrow. It's being delivered by truck, so when I get that, I'll share it with you. It looks like an interesting tool. If you got any questions or comments or suggestions, post them in the comments below, and I'll keep you guys posted as we make progress on this. All right, thanks for watching, and we'll see you guys next time.